Hello, everyone. I'm very happy to be presenting the official launch of the eFootprint interface to you. It's been quite a while that the interface exists as a prototype, but now is the time when it finally reaches its V1 version. And very importantly, now it is hosted on Boavizta servers and accessible via Boavizta URL. Before we dive into really working with the interface, I just want to introduce the concept of eFootprint for people who don't know it with a simple graph. So it's on the next slide. Thank you, Ocean. So the goal of eFootprint is to be able to generate this type of graph. Here, I'm going to only be talking about CO2 emissions, but of course, the same reasoning could apply to other environmental indicators. For now, it's only CO2 in eFootprint, but it's going to evolve in the medium term. So if we focus only on CO2, the goal to be able to prioritize the eco-design decisions is to be able to generate the graph of the cumulative CO2 emissions of a digital service across time, year after year, because the service will be used differently during those years, that there will probably be some growth. And we also want to be able to generate this graph for any subpart of the system, meaning the servers, the data storage, the network, and the use of devices by the user. When we have the first graph, the black one, already we are able to make quite a lot of analysis to understand where the emissions come from in the system and already know which area to focus on the most. And then once we have this representation, we are able to make a simulation of a change in the future. And like, for example, say in 2026, I plan to make this ambitious eco-design action. So I simulate the change in my tool, and then I can compare the simulated emissions, my green line in the graph, with the baseline emission. And the difference between the two is going to be the return on investment, the environmental return on investment of the change. And by doing such simulations, we can compare and detect which ones have the most impact. Of course, on the next slide, there's like the same graph, but for this time for features, not for eco-design actions, because you want to have the ability to follow these principles every time you make a change to the system. And most times it probably won't be an eco-design action specifically, but it probably will be a new feature. And in the same way, you want to know how much more impact the new feature will have. Probably the new feature is going to consume more resources, especially if it's AI. So this capacity to understand the footprint across time and make simulations in the future really is at the core of eFootprint. And there's a second very strong conviction that you are going to see in the tool, is that the modeling of the digital service should include the usage journeys. It should describe what the users do with the service, because if you're able to describe your service in this way, you become able to make simulations that allow to answer questions such as, how will the impact of my service evolve if I add generative AI to my user journeys? You can make changes on your user journeys as well as on your infrastructure, so you become able to understand the system very, very finely and to make to simulate complex changes and also like functional changes. And now, last slide before we go to manipulating the interface for real. So the tool, it's two Python package. There's the core that makes all the calculations, that codes all the logic, all the methodology. It's available in the eFootprint package at Boavista. Then there's another Python project that is the interface. It's also open source in the Boavista repository. And the interface is now hosted on Boavista server and now has a stable URL. So it's efootprint.boavista.org. I'm sharing all the links in the chat. There's also an open roadmap that you can check. And now I ask for a volunteer among you so that this person can share their screen and go to efootprint.boavista.org, and we are going to make a modeling together and like understand the tool and ask all the questions that you want. Okay, so let's go. You can click on Start Modeling My Service. And we see here that the interface is divided into three columns. We can focus on the middle column first. It's the column where we make appear the usage journeys. So a usage journey, it's really what it is normally in IT language. It's the series of steps that users do on the service. Here we are going to model only one usage journey, but eFootprint is capable of having all the combinatory freedom that you want. So you can have as many usage journeys as you want, and you can represent complex system. When using eFootprint, I recommend that you start by just having one or a few usage journeys, like very high level, like really what people do on average, so that you have a simple modeling to start with. You get some orders of magnitude, and depending on the orders of magnitude that you get, you decide or not to go further in the precision of your modeling. So our first usage journey, we can say like maybe you can rename the first step. It's going to be like a login to a social media platform, for example. So the login is like really quick. We can say let 1 minute. Like here, the figures won't matter too much. It's more to show the spirit in which you can use the tool. So the time spent by user is going to be used to compute the power consumed by the user device, but then the requests that are made to the servers when the user is doing the step, probably they are going to last a much shorter time. So you can save the step to save its new name. Then we can have another usage journey step, and it's going to be like let's say scroll my feed and watch videos. And we do just two steps, very high level. We could be much more precise. Like maybe it's like 15 minutes, and we are going to model the requests that are made during those steps. So for each usage journey step, you can add as many requests as you wish, because in reality, there can be many requests that are made, maybe requests to different servers. And so, Amiel, you can add a server. We need to have a server before we can add a request to a server. If we look at the server types, the server by default, it's an AI server with GPUs, but we are going to talk about AI just after. So in available server types, you can click the list.
This one?
Yeah. Okay, we don't see in the screen sharing, but yeah, there's a list.
Okay.
So like if you select the CPU server,
yeah,
for starters, so we are going to take a look, like, yeah, the custom server. You can scroll a bit, and we can look together the form to create the object. So this object, it's really the custom server. It's a server where you have to input yourself all the technical details. So Amiel, if you scroll a bit, we see that we have some like very important parameters like the lifespan, the amount of RAM, the amount of compute, also the average carbon intensity of electricity. That is a very important parameter, like the carbon intensity of the electricity that the server is running on. If you show the advanced parameters, we can see that there are a few more parameters that are much more difficult to know when we make the modeling, and we are gonna see how the Boavizta API will help us to fill those parameters. So let's hide them. It's just to show that like the footprint objects have quite a lot of depth, and it allows for the modeling of complex system, but we will see ways to use the footprint without having to know how to fill all those parameters. Anyways, you will always have default values, but we will see also a simplified forms. And then a server has an associated storage, and that's same thing here. We have like most important parameters, and then we have some advanced parameters, but we don't need to go into the details of all the parameters here. Let's get back to the list of servers. We are not going to use this big form to create our servers. We are going to use the Boavizta form, the cloud server form. So here, the idea is that eFootprint connects to the Boavizta API to give users the possibility to create a server, but with a much more intuitive and simple form. So here we create a cloud server, and we are going to give the provider the instance type. And those of you who know the API will recognize the same type of information that the API uses. And we also ask like the parameters, some of the parameters are the same as with the custom server that we saw before. And when we create a server with this form, what eFootprint will do is it will use the API to fill the technical parameters of the custom server that we saw before, so that we come back to the same parameters in the end. A server is always described with the same parameters, but with the help of data sources like the Boavizta API, we can have simple forms that generate some of the parameters for us. So it lowers the bar for entry, and it allows to make good modelings without ourselves going to look up all the data. So let's create a server. You can just click save. We'll keep the default parameters.
Don't want a more fancy name?
You can change the name if you want. We have a default name, but can be like it's the platform, like it's the social media platform server. So now we can add a job to the platform. So the login job, you can click add new job on the first step. And after we will add a service. So when we add a job, we can choose a server and we can choose the service used. Now the only service that we can choose is it's a direct call to the server because we have no installed service on the server. So we have to give ourselves all the parameters for the job. And in eFootprint, a job is described as an amount of data transferred, an amount of data that is going to be stored on the server storage, a duration. And if you go to the advanced parameters, here are some difficult ones. It's the amount of compute and RAM needed by a single individual request to the server. This is very technical part, but it's also a very important one. That's typically data that you will want to get by benchmarks in real life, but we will see how we can, in some conditions, have good values. And it's very important data because what eFootprint will do, like overall, a big thing that eFootprint does is, given the usage journeys and given the frequency of usage that we describe in the usage patterns section, eFootprint will compute a number of requests in parallel to each of the servers across time, and that allows to compute the server load across time and deduce their energy consumption and their footprint. So when we make changes to the way people use the system, either in the usage journeys or by changing the usage pattern or like adding a new usage journey or a new usage journey step, eFootprint will automatically update the number of requests in parallel, and so we will know how the infrastructures respond to the usage, which allows for very interesting simulations. So let's keep default values. So it's just a bit of data transferred. Yeah, it's just a logging page. Like we could have increased the data transferred because the page is maybe a bit heavier. Yeah, let's edit the job. You can click the job. Let's say like data transferred. Let's say it's you can add a 0, like it's 1.5 megabyte for the for the login page, but then the data stored is, let's keep 100 kilobytes. It's just like some logs. Okay, good. So let's save that. And now the user is going to watch videos, and that's the opportunity for us to install our first service. So let's go back to the server, and we will install on the service on the server a video streaming service. We have a very generic web application service that is available, but let's select instead the video streaming application. It has a name. All the parameters are marked as advanced because they are quite difficult for beginners. So you can find like bits per pixel, static CPU cost, stuff like that. This type of object in eFootprints, it's not at the core of eFootprints. It's very easy to create in eFootprints such objects to represent new service. What a service is fundamentally, it's just a base use of RAM and CPU on the server, and then it gives access to simplified forms that will compute for us how much resources the jobs use. So let's install the video streaming service on the server. Let's keep the default values, and people who are interested can then deep dive. I will show you how we can use the interface to deep dive into the computations that are made by eFootprint. But for now, let's add a job in the watch video step. And now in the service used section, you can still make a direct call, but now you have access to the video streaming application. And now we can see that we have access to a much more intuitive form. And like for the video, almost anyone among us would be able to fill this form, the resolution of the video, the duration, and the data stored. It will be more like some log data, so we can keep it at 0. It's the data stored on the server side. Mm-hmm. So let's say like let's put 0.2. Well, here.
Oh, sorry, that's too fast.
Yeah, we could see it like this, but it would be like the user spends 15 minutes, but then the job runs for another 45 minutes on the server. It's technically possible, but let's put like 0.2 for the video duration. Later, there will be the possibility to change the units in the interface. Like for now, it's a bit rigid, but it's already quite usable. Okay, good. So we have a usage journey. We know how much time people spend, what requests are made to server, but this is an individual usage journey. Now we need to know how much time the usage journey is executed and where and on which devices. So you can click on Add Usage Pattern. That's the usage pattern object that is going to give us this. So again, you have all combinatory freedom. So you can say like usage in France for the name of the usage pattern, because you could create as many usage patterns as you wish for a given usage journey, so that you can have like different usage in France, in the US. Like it could be the same journey, but used differently in different countries. And of course, the time zone difference is going to be taken into account. If the same server serves the US and France, then the time difference will mean that day use in the US and France will be mostly even from the server perspective. You select usage journey, the device on which the journey is executed, the network through which the data is transferred, because it's not the same energy that is used between a Wi-Fi network or mobile network. And the country will give us the time zone and also the carbon intensity of the electricity of the user devices. For the server, it's a specific carbon intensity, because it could be quite different. But for the users, we give a country carbon intensity. And now we need time series data. So we can choose the start date of the modeling, the duration. Here we can keep 3 years. It doesn't matter so much. Like there's a limit at 10 years in the interface, but technically, eFootprint is able to go further. Maybe that's a limit that we are going to adjust depending on the need. But I think already projecting to 3 or 5 years, it's already quite good. And here the form is very simple. You can enter an initial number of usage journeys. So I don't know. Let's say like 12 million, because there are 12 million French households. Okay, so it's like here it's every month for each household in France. There's this usage journey is executed, and we can put a growth rate like 5%, 10%. We see how the time series adapt. In the interface, the time series form is quite simple. Medium term, it's going to be a bit augmented so that we can go in more details. But in the backend, on the eFootprint side, if you use the eFootprint Python package, of course, you can put arbitrary data in eFootprint, and it's an hourly granularity. So you have all the freedom to describe the complex ways in which the usage journeys are executed hour by hour, year after year, and able to make the projections. Like if you're a startup or you're launching a new service, you can make hypotheses like it's going to be used more during those hours, and the growth will be that much, like to mimic the business case, so that you can have orders of magnitude of the projections of the impact of the system. Good, and now you can click Save, Amiel, and congratulations, you've made your first eFootprint modeling. So you can click on Show Results or on the bottom band. And here we have very simple graphs. On the left side, it's the yearly CO2 emissions. We can see that it's growing year after year because the usage is growing. And on the right side, it's the cumulative view of CO2 emissions. So it gives us a very important number, which is like the maximum number on the right. We see we are a bit above 3,000 tons of CO2 equivalent, which is very much, and that's normal because here we've put very big numbers. It's 12 million people doing this usage journey per month, but it shows how important scope is, how important the magnitude of usage is, and we might have cases where in relative terms, there's a big eco-design opportunity, like a corporate website that is badly designed, but maybe the corporate website could have its footprint reduced by 80%, but if the corporate website is only visited a few thousand times per month, then in the end, the environmental impact of this 80% reduction will be, in absolute terms, not very much. But if the service is very big, we can see that smaller relative adjustments are going to have an interesting absolute weight. And of course, what's important is the absolute weight, because we want in absolute to reduce the CO2 footprint, and we want that the amount of CO2 that we can reduce on the system is in adequation with the effort that it would take us to reduce. So if we see that, for example, the network usage here, we see that it's about 1,000 tons of CO2 per after 3 years. So we know that if we have quite easy ways to reduce the bandwidth, we can have a very interesting impact. And again, coming back to this idea of a return on investment. Now let's do a small simulation to see this in action. So you can click again on the top of the results page to put it down. So like
Here?
the down arrow.
Okay.
Yeah.
Yeah.
So let's click on the video streaming job. Now you can click on the results in parallel, so we can have both in parallel. Okay, so here we see that we arrive at like 3,000 tons of CO2 after 3 years. And now we can make a very simple eco-design simulation. The interface doesn't have yet the possibility to say, okay, I froze the system, and in the future, at this date, I make this list of change, and here is the simulation, and see like the two graphs branching as in the slide I showed you. But it's gonna arrive in the coming months, and it's already implemented in the eFootprint package. You can already do such simulations in eFootprint. Here, what we can do is simply change a value and see in real time how the system is recomputed. So let's say that instead of having a 1080p resolution by default, you change the resolution to a 720p. Okay, so we keep in mind it was about 1,000 tons of CO2 for the network and 3,000 tons total. So, and if you click save, now we see that we came back to 2,500 tons of CO2, and like the network impact has been divided by 2 because the weight of the videos have been divided by 2. So in this case, it's very clear that like changing the default video resolution could have a very big impact. Are there any questions at this stage?
No question, but that's very impressive. Really enjoy it. I like it.
Thank you very much, Amiel. And it's not over. We still have a lot to cover. So for the energy mix we use here, the country that Amiel has selected on the usage pattern side, it was France. So the energy mix was France, and it's like, I think it's 85 grams of CO2 per kilowatt hour that I use as value. But you could add another usage pattern with another country. And on the server side, it's not the country that you give, but you give directly the carbon intensity of the electricity. Does anyone else want to manipulate the interface for the deep dive part into how the calculations are made and which sources are used? If everyone is too shy, Amiel can keep steering, but don't hesitate.
I'm happy to do that, Vincent, if you want.
Okay, great. Thank you, Caroline. And thank you, Amiel, to be the first volunteer.
You're welcome. So, with me. No.
So I need to share my screen, right?
Yeah. We're going to remake the simulation very quickly, like not touching the names. It's gonna take just a few seconds. I think Ocean is giving you the rights to share. Okay.
Works?
We don't see your screen yet.
Yeah, this window.
Yes, it's good.
Okay. I'm looking for my menu window. Here we go.
Okay, nice. Okay, the definition is a bit low now. Okay, it's better. So let's go a bit quick. So you can go to Add Server, select the cloud server.
Here? No.
Yeah.
Yeah.
And then you click Save.
Cool.
So here you downloaded your model, but click Save. Yeah, it was a save button, but it's for saving the model as a JSON file so that you can keep it on your desktop. Because the data is not saved on eFootprint. There's just a cache data, so you can interact with the system. But if you want to keep a modeling long term, please do use the save button that Caroline just used to save a file of the modeling that you can then upload, so that you're sure that you can keep your data. So you scroll and you click save to create the server.
Cool.
Okay, now you can install the streaming service, and we are just going to have one step with the streaming job.
Do I take this one?
No, the streaming application. Good. So you can click.
Save again?
No, the streaming service was good.
Pardon.
Yes.
C'est
So you
bon.
can click save. Now adding the job.
Add the job here. No, not here. See?
Yeah, it's good. It's good. Now you can scroll and click save. So you save the job with the default parameters. Okay,
Cool.
and now on the add usage patterns side, you just have the usage pattern on the left column to give the data of
Yes.
the okay, so here it's the edge usage pattern. We are going to cover that at the end if we have time, but now new usage pattern, and you just have to put an initial number of usage journey, so it can be like 10,000 or 1 million. You put as many zeros as you want for the initial number of usage journey.
Je vois pas où c'est ça.
You scroll down. It's the second before the end.
Yeah.
Yeah, here.
Okay, how many do you want me to put?
Like 1 million. 1 million per year.
Okay.
Per month initially. Okay, very good. Very good. So you can click save. Okay. So now coming back to the results page, we will have slightly different, like very different results from last time. Here, the users spend only 1 minute by default, so it's not very coherent, and most of the impact come from the network. Okay, you can click sources on the top left corner. And here we have an overview of all the sources that are used in the computation and which object they belong to. So that's just a way to give a transparency. In the in the future, we might make this view editable so that it's possible to change a source value very easily. You can also export it to Excel format. And now if you go back to the modeling, if you click the down arrow.
Yeah.
Yes. And now for every eFootprint object, once we have results that are computed, we can go explore each object and see how eFootprint has made the intermediate calculation. So if you go to the cloud server, for example, if you click the cloud server, and you scroll to the end, now we can see that there's a new section. It's the calculated attributes of the server. There's quite a lot. We can see that there's an API call response as first calculated attribute. That's the Boavizta API call response. And then there's quite a lot of intermediary computations, like the hour-by-hour RAM and compute need, how much RAM is available, the raw number of instances, the number of instances that is computed depending on whether the server is auto-scaling or not, etc., etc. And at the end, we have the instances fabrication footprint and the energy footprint. Let's look like, for example, the available RAM per instance, the 26.8 gigabyte. If you click on the formula button, yes, the one on the left, for all the calculated attributes in eFootprint, you can know what were the variables that were used for the calculation, and you can know the formula. So in this case, the available RAM per instance in the cloud server has a very simple formula. It's the RAM multiplied, like it's the total amount of RAM in the server multiplied by the utilization rate, because the server will likely never go to 100%. And we subtract the amount of RAM that is already occupied. And the RAM that is already occupied on the server, it's the RAM taken by the video streaming application. And if you click see the calculus graph, we can even have like a genealogical view.
Oh, pardon,
Yeah,
pardon.
it's a bit
Sensitive.
raw. It could be integrated more nicely in the interface. That's the V1. So as a child node in this graph, you can hover on the child node, like the one on the bottom.
Yeah.
And we can see again, if you stay on it, we can see again the formula and the values and the result. So we can really understand how the number has been computed, and we can go up, and we can go up to the very first sources. So we can see, for example, like on the left, if you go to the RAM, we can see that here, I told you that it's a server that has been created thanks to the Boavizta API. We didn't give directly the RAM, we gave the provider and we gave the server type. And it's the two top node that we see in a Burgundy. And what eFootprint did is it called the API. We can see the API call response node just below. And then it extracted from this response the amount of RAM that the server has available. So that's a nice way to explore eFootprint's methodology without having to go to the code. Of course, if you go to the code, you can also see the formulas, but it's a much more accessible way to make sure that formulas are coherent and to like find ways in which the computations could be made better. And if you come back to the eFootprint interface,
So I don't know how to come back.
it was a new. It's a new tab. The tab you're in.
Wait.
Yeah.
Sorry, I'm back.
And if you scroll, like this quantity was just a single number, but most of the intermediate calculations that are made in eFootprint are actually time series. So for example, if you click on raw number of instances, a bit below, yes,
Yeah.
you can click on it and you can see the time series. And in the same way, you have the input variables, you have the formula, but you can see across time how it evolves. In our case, most likely in this case, the server is underused. So it's just one server. Oh no, it's 60 servers. Yeah, it's 60 servers, 60 plus servers, and the usage is always the same. There is no growth, so we always have the same number of instances. And the formula is here we compute which is the limiting factor. Is it the RAM? Is it the CPU? And we take the maximum between the two. So we won't go into details of footprints calculations during this presentation, but yeah, just to tell you that it's possible to go and explore on your own when you make your modeling. And you can also, like, if you click on the, like, let's click on the calculation graph of the energy footprint, like the last one. Yeah, that's the calculation graph. And we can see that when we go to one of the last calculated attributes, it uses all the previous ones. So we can have calculation graphs that are more complex because they go back to the inputs. So they can become quite big. Okay, let's go back to the interface. Are there any questions? Okay, so we are going to add a bit of AI to our system. First, maybe let's balance a bit the modeling. So you can click on the usage journey step.
Usage journey step.
On my first usage journey step.
Okay. And you want to go here?
Yeah, click on it. No, click on the first one so we can edit it. Yeah, and for the time spent by user, we can say it's 60 minutes because the job was an hour of video. So let's say that it's 60 minutes. If we look at the results now, it should be more balanced between the network and now it's much more balanced. The devices take more responsibility in the footprint because the time spent by user and the time of the request are coherent. Good. And now let's answer the question: what happens if we add a usage journey step? So let's add one, and we can call it like a debrief with my AI friend, where we're going to talk about the video with an AI. And let's say the user spends like 3 minutes exchanging ideas with an AI. Okay. Now, what you could do, you could click on Add Server, and you could then install an AI service on a GPU server. So here, by default, it's a GPU server. So we can see that its compute, the unit is a GPU, and we could create a server that way, and we could install a generative AI service on the GPU server, just like we installed a video streaming service on our CPU cloud server. But instead, we are going to use the Add External API button. It's going to do this work for us. What it will do, like, it will only give us directly the service that we want and that we want as an external API, and it will create for us the server with the right capacity, and then we will see the server appear, and if we want to edit it, we can. So I'll let you choose your favorite Gen AI provider and the model that you want to use.
I don't have a favorite, but okay.
Okay. Let's use like GPT-4o, for example, by OpenAI. It's one of the most popular, and it's quite big. And here,
the turbo, or
use any. The GPT-4 is going to be very big, but it's okay. You can click save, and we will see that the servers, like if you open the accordion, we will see the service installed. And if you click on the servers, if you click on the server just below, like the servers associated with the model.
here?
So here you click on the install service, but if you click on the title of the server just above, Now you have access to the server characteristics, and we can see that the compute, if you scroll to the top, it's 53 GPUs for GPT-4. So that's really a lot. That's a huge model, and the models, they evolve quite quickly. Today, very few people are using GPT-4. People use smaller versions of GPT-4, like GPT-4o. So we will get very inflated numbers. That's okay. But if Footprint computed the exact number of GPUs that we need to be able to host this very big model. And in this, yes.
Do you want me to change it, or are you good?
It's okay. It's okay. It doesn't matter. I just give the information to like expect the figures to be very big, but it's fine. And here, so you notice that it's a very simple form. It's just the name of the provider and the name of the model. Here, I don't link to Boavizta API to get this data, but if Footprint connects to Ecologit's project that most of you might know, to get the data from Ecologits. So you can, let's open the add new job form.
Where is this?
Add new job, like in the usage journey step debrief with my AI friend, you can click on add new job, because now we need to create a job to call the generative AI server. Let's open the results page so that we will see how the results page evolves. So yeah, you can open it in parallel. So we have about 1,000 tons of CO2 after 3 years in cumulative. Now you can choose a server to add your new job. Now you choose the generative AI server. And now you could make a direct call to the GPU server, but again, you would have to yourself tell how long the job lasts, how much GPU it uses, how much RAM, etc. And here, since we have installed the service, we have access to a very simple form, and we're using generative AI, so it asks us how many tokens the model will output. So let's say it's like, 2,000 tokens or 1,000, like just a few minute conversation, and you can click save. And let's open the results page again. Okay. There was a small bug, but now we see that we arrive at 30,000 tons of CO2. So we multiplied by 30 the impact. We see that the server impact is become the vast majority. But I warned you, this is very inflated numbers because GPT-4 is a very, very big model that is not used anymore. But when it first started 2 years ago, that was what GPT-4, that was how big GPT-4 was. It was really like about 50 heaters in parallel pulsing to answer your request. And that's one of the very difficult things with generative AI, is that it evolves super quickly. So like the cost of GPT-4 has been divided by maybe, I don't know, 10 or 20. So now using GPT-4o would be much less than that. But that's also why it's important to be able to audit the computations and to make sure that they are up to date and then they reflect reality enough. Okay, nice. So it's quarter to 12. So I think I won't cover the edge part, or maybe at the very end, if we have time, maybe I'll do it myself. In 2 words, the edge part is the ability to have a usage that depends on the number of devices rather than on an outside usage. So it's like, for example, I'm a video game company and I want to know the impact of my new fleet of video game consoles. Then I will describe the processes that run on each individual console, and I will give as input the number of consoles sold. So it's not the same as the web case that we just saw, where you can increase the number of servers, but it won't increase your usage. But here in the edge case, your usage depends on the number of devices you sell. But I want to make sure that we have time. So if you have questions, please go ahead. And I just have 2 slides left for the presentation.
Do you want me to share them?
I can take the sharing, but I'm not sure I can now. Can you please give me the access?
Yeah, sure.
Thank you. No questions? Everything clear?
Yes, maybe Vincent, can you hear me? Yeah.
Yeah.
I can put my video. If I want to compare, for example, OVH and Scaleway and Green for Cloud, because I hesitated between the three, I need to collect the related data for each service, because for OVH you can select hosted public or private cloud. It's different, but I need to get the data from OVH. How can I get the related data? And I'm not able to use your tool. My dev could use it, but I have to convince him to use it. How can you assist about that? Or do you have some insights, some advice about that?
Well, for the data part, eFootprint doesn't give directly data. eFootprint will fetch data on other projects that are much more data oriented, like for example the Boavizta API. Maybe at some point eFootprint will allow to share modelings and maybe have template modelings that will allow user to get inspiration from the work of other people, and maybe it could create some examples of data. But mostly eFootprint is a modeling tool, so it gives the ability to manipulate the data, but it will get the data elsewhere. So yeah, getting the data is hard, and in some cases you won't be able to have the data you want short term. But what's interesting with eFootprint is at least you can use hypothesis and still have orders of magnitude. And I think it's much better to use hypotheses, make them appear transparently, and have orders of magnitude that can guide your decisions than ignoring the parts of your systems where you don't have data, because it comes down to putting a zero hypothesis to those parts, and it's not even transparent because it's mostly out of the minds of the people reading the analysis. And then for using eFootprint, what I recommend is that in a product team that is responsible for developing a digital service and who will want to control its environmental impact, eco-design it, I recommend that one person is the eFootprint reference. This person can come from the product or from the code side. Like, this person doesn't have to know how to code, but she will be responsible for gathering the data, understanding how the tool works, and making sure that it stays coherent with the reality and that it helps making better decisions. So it will be one modeling for the whole team, and the whole team will be interested in understanding enough the modeling so that it can have a role in the end decision alongside with all the other aspects of the decision. But one person will have to be a bit more specialized and have the ownership of the tool.
Okay, thanks. I think we will focus on how AI consumption, because it's politically, I know And maybe
Yeah.
what's your point of view? Maybe we could discuss further in the following weeks, because we work on the CSR, and we need to prove that we are frugal. We use AI with frugality.
Exactly.
So between models, there are some differences. We use Mistral as by default, and we don't have. We need to contact maybe Mistral to get some advice on the models to use, and if some models are more
Yes. Well,
frugal than others.
yeah. In eFootprint, you can clearly see the difference between models. If you change the carbon intensity of the model and the size of the model, you can see that the difference can be really enormous, like 100 times difference. And I will touch on the topic of how to go further in a few minutes. I want now to share my screen and let Mihalina talk about the logo of the tool. Do everyone see the slide?
Yeah, thank you very much, Vincent. Perfect. Thank you for the presentation. And I think that at Boavizta, we like to know what members think. So that's why we will need your help to understand as well your preference and your thoughts. So as you can see, the model of your footprint is finalized, the interface as well. And we are missing, I believe, mostly the logo to add as well on our Boavizta page with the tools. So we are looking for the logo that can represent the idea, like Vincent was telling as well at the beginning, that would be coherent with other tools. So here on the page, you can see the logo of our 5 Boavizta tools, which are quite simple. Vincent at the beginning of the presentation showed you the 2 graphs where he had seen, for example, the eco-design impact on the service, and where we can as well model the impacts when we plan different features. So we wanted to ask, after all the presentation that Vincent did, maybe which version of the logo would seem for you the most coherent or would represent the idea of your footprint. So that's why don't hesitate to, if you are checking your emails, don't hesitate to check the page. Think maybe a moment, take your time, and then in the comment section of the meeting, you can just write which version you prefer, version 1, version 2 of the logo, or version 3. When we were choosing those logos, we were thinking about how we can represent, like I was saying as well before, this idea of modeling or maybe of potential impacts in the future, working on the conception, and we somehow tried to implement it here. But we would love to know as well your view. So don't hesitate to take a moment. I'm checking the time. And so share with us the preferred version you have. And as well, if you have any other comments, maybe if there's a logo that you don't like at all, don't hesitate to share maybe with us what would be better.
Thank you,
So
Michalina.
Thank you, Vincent.
And yeah, we have just a few minutes left. I just want to talk about the hackathon. So if you're interested in the tool, let's meet at the hackathon next week to work on the integration of eFootprints in the ecosystem. So there are several subtopics that we can tackle at once, or like depending on people's preferences. Of course, it will be an opportunity to test the tool and give feedback and ask all your questions. There's a topic around the connection opportunities with other tools. As you saw, eFootprint is already connected with Ecologit for AI. It's also connected to the API, the Boavizta API, but this connection is incomplete. There are quite a lot of data in Boavizta API that are not available yet in eFootprint. And I think it would be great to map what is and what is not in eFootprint and have some idea of what would be needed to create the connection. And like if people want to start developing the connection, it will be also possible. There's the question of methodological alignment. There are like mostly what eFootprint does is outside of what has been worked on by Boavizta so far, because eFootprint is mainly focused on computing a number of requests in parallel depending on the usage journeys. So this is like very it's just logic mostly. But I'm thinking like especially for how much energy the CPU and the RAM consumes, for example, it's not calculated the same way in eFootprint and the Boavizta API yet. So it would be great to again map where there are differences and make sure that the tools are coherent. And then there's the question of the positioning of eFootprint. It's a quite new tool. I'm not aware of other tools that are so much simulation oriented as eFootprint, and it's complementary to the other tools that are already present, and it uses some of the other tools. So I think there's some group thinking to do around positioning of eFootprint and the coherent story about all the different Boavizta tool and which tool in which use case, what are the different roles of different tools. And finally, the communication strategy. This is an avant-première. The eFootprint.boavista.org web application is just live. I think it's good if we keep a few weeks to like have the hackathon, gather ideas, gather feedback, and then launch a proper communication strategy more like by like in October, like mid or late October, so that we have something that is structured and solid, and that's an important part to have the tool be really used and useful. Thank you very much for your attention. I put the logos again. Please vote for your favorites. And if you have a last question, it's the opportunity. And otherwise, I invite you to come to the hackathon so that we can discuss more.